Hello all, let us talk about Darlington pair amplifier circuit. Okay, so before going to the Darlington pair amplifier circuit, let us look at a simple uh, transistor based circuit which has a single transistor and then there is a collector resistor. Okay, and the output is connected between uh, the collector terminal and the resistor at the end. Okay, so this is the circuit which is commonly used, right? Everywhere we do find this. So for this, we know the relation between the collector and the base, where the collector current is given by IC is equal to beta IB. Okay, so this is the relation, right? So the collector current and the base current relation is determined by the current gain of this transistor. Now, in some scenarios, we might need more gain such that we get more collector output, okay, for a given base current. So in such scenarios, this may not suffice our requirement. We might need to have another beta current gain such that we have a higher gain. So in such cases, we use this kind of circuit which is called a Darlington pair. You can see here there is a NPN to which there is a base input and collector is tied to the voltage, and then the emitter output is connected to the base of the next transistor, and then the output of the second transistor can be used to connect to your load. So in this case, this will have a current gain called beta 1. This will have a current gain called beta 2, and the overall current gain of this entire Darlington pair is beta 1 into beta 2, which is multiplication factor of the current gain, which is very high current gain, right? So this circuit is actually used in the power amplifier circuits or audio circuits. So many applications are there for these circuits. Now these scenarios, right? If we see the important characteristic of these transistor circuits is the input impedance. Okay, input impedance means the impedance seen by the circuit that is connected to this amplifier circuit is high. Okay, uh, and then the output impedance is low, which is a very important characteristic to become a buffer. Now, considering that there are two transistors, so the input impedance of this Darlington pair is much higher than the circuit. So it plays a very crucial role to be used in the buffer circuits as well. So that's one more advantage of having the Darlington pair. So if we look at the circuit connectivity of these Darlington pairs, you can see this is a circuit that is drawn in LT spice, and you can see here this is a simple NPN circuit where we used emitter follower output to connect it to our load. So emitter follower we know, right? The load is connected at the emitter side. Generally we connect it at the collector side. So for this NPN transistor, there is a pull up at the input which actually keeps the transistor in a default on condition. So we have the input that is coming from here, and then the output will be present here, where we have a current gain of beta. Now this is a normal circuit. If we come to the Darlington pair circuit, we can see the first transistor and then the second transistor, followed by the output connected to the load, and the input current is the same. So now you can see the input is given from a fixed DC, and then the supply, collector supply, is given as 9 volts. So again, this depends on what transistor you select, and then this actually is a DC circuit. If you have a AC input here instead of a DC, so you will have a series capacitor here, which actually helps for coupling. So for AC analysis, we have a AC applications and AC analysis to be performed. We have a capacitor there that differentiates between a simple DC input and a AC output, which is very clear, right? And then, as we said, these two gains combine to give the current gain, which is, if it is beta 1, so the current gain is beta 1 into beta 2. So using LT spice, we can perform DC analysis, DC operating point analysis, normal transient analysis, and also AC analysis for this circuit. And then when we go to the actual simple application circuit, so as we said, Darlington pair has several applications, and one of the important characteristic is the current gain. So if you need more current to be sourced to your load, and where BJT is one of the usage there, Darlington pair is what you can use safely. So that is, this circuit basically shows such a application where this is a Darlington pair circuit, and then you have a speaker which is connected between the collector terminal and the operating input. Operating voltage that is at the collector side, and then you drive your circuit from the base. So this is how we generally use the Darlington pair in in audio application. So one is audio application, and second thing, it can also be used as a buffer to, because it has a high input impedance and low output impedance. So that is the reason why you can use it as a buffer. So when we have high input impedance, that the simplest advantage we can say is impedance is high, the input current is low. The output impedance is low, it allows more current to flow into the load, which is very important, right? So buffer is another important application of Darlington pair. So this high input impedance and low output impedance is required generally for impedance matching in circuits where you don't want to load your circuit with the output load that is connected, a very important characteristic in circuit design. So this is about Darlington pair. Please post if you have any questions. Please post if your observations on Darlington pair and what disadvantages you have seen. Definitely there are some disadvantages that are considering the first SPN circuit that we have seen, the turn on of the circuit takes some time than the other one, which is one disadvantage that we can see. Hope we gave a glimpse of Darlington pair. Please post your questions. Thank you.